Okay, so let's look at number 1 on some great kinematics questions. It's a person driving her car 50 kilometers per hour and approaches an intersection. Just as the traffic light turns yellow, she knows the yellow light lasts for 2 seconds. So the time for the yellow light is 2 seconds before turning red. She's 30 meters from the near side of the intersection. The intersection is 15 meters wide. Her car's maximum deceleration, -6 meters per second squared, acceleration, ignoring. Should she stop or should she go through? So you're going to need to do it twice. Once for stopping and once for going through. So her initial velocity in both cases is 50 kilometers per hour, which of course you have to change to meters per second. And that's 13.8 repeating meters per second. And it's the same over here, whether she stops or goes through. And don't lose the repeating. If you're going to lose the repeating, it becomes 13.9. Tells us her maximum acceleration when she's slowing down is -6 meters per second squared. Now over here, it doesn't tell us her acceleration, but it tells us that she can go from 50 to 70 kilometers per hour in 6 seconds. So that's kind of like a little aside, where the initial is 13.8 repeating meters per second, the final is 70, and the time is 6 seconds. Now she doesn't have 6 seconds. They're telling us this so that we can figure out what her acceleration, her maximum acceleration speeding up can be. So this is 19.4 repeating. Okay, so we'll come back and use that to get her acceleration later. But first, let's see if she can stop. So if she's stopping, then the VF will be 0. Now there's a couple of things that you could do, but you need to be careful. So some people would probably find, how long does it take her to stop? But how long it takes her to stop, when you do that, you don't actually know where she is when she stopped. So you might find it takes her 2.5 seconds to stop, okay? And that's all fine, but that doesn't mean she shouldn't try to stop, because you can still be moving on a road when the light ahead of you is red. You just can't be moving through the intersection. So finding the time that it takes her to stop isn't all that helpful unless you then use it to find her delta D. Because in the end, you want to find the delta D. You want to see how far is she moving while she stops, and is she going to be through the intersection or not. So rather than find time, I would just find delta D directly using VF squared is equal to VI squared plus 2A delta D. Okay, so you're looking for delta D, so take the VI squared over, subtract it, and divide by the 2A. Okay, and you're stopping, so VF squared will be 0. So this will be negative, that 13.8 repeating, squared, divided by 2 times -6 meters per second squared. Okay? And so when, the whoops was to my calculator. So when you do this, you end up getting 16.075, assuming I didn't do that wrong. Meters. So can she stop? Yeah, she can, because the intersection's only 30 meters away. She only goes 16.05. Not only can she stop, she's probably going to cause an accident if she stops with her maximum deceleration, because she's going to stop like 14 meters before the intersection. So she doesn't need to slam on her brakes. She actually has more than enough room to stop. All right, so now for the going through. So the first thing we should find for the going through is her acceleration. So A equals VF minus VI over delta T. So A equals 19.4 repeating minus 13.8 repeating divided by 6 seconds. So A equals 0.925 repeating. 0.925, and all 3 digits are repeating, meters per second squared. So now we have her A. We have her VI. And we know how far she needs to, oh, actually, let's do, we know how long she has to go through it. If the light's going to turn red in 2 seconds, it means she has 2 seconds. Where will she be at the end of the 2 seconds? Can she make it through? Okay, so this time we do want to use the time. So we're looking for delta D again. VI delta T, 1/2 A delta T squared. So 13.8 repeating meters per second times 2 seconds plus 1/2, whoops, out of room, 0.925 meters per second squared, and that's repeating, times 2 seconds squared. So delta D equals, so squared times 1/2 of 4, 2, plus brackets 13.8 repeating times 2. And I think you get, if you don't round at all, you get 29.4925 meters. So how far has she traveled when the light turns red? 29.492 meters. That means she's right here. So you might think, oh, she's okay because she isn't in the middle of the intersection. That's true, she isn't, but the light is turning red and she is now going something faster than 50 kilometers per hour because she's been picking up speed. So she's actually on her way, just entering the intersection when the light turns red for her and green the other way. So no, she should not go through. She's that Dinkeldorf you look for when you're sitting here at the red light and it turns green, and the first thing you do is not step on the gas. The first thing you do is look both ways for her to see if she's like, oh, I can make it through. Okay, so that's number 1. The other one I asked you to look at was number 4. So let's take a look just in case you got stuck. So there's a police car, which is one part. Oops, my computer just went to sleep. There we go. Police car, couldn't see the question. A police car at rest, so VI is 0, is passed by a speeder who is traveling a constant 110 kilometers per hour. So speeder, constant, 110, which of course you need to change to meters per second. So divide by 3.6, and you get 30.5 repeating meters per second. The police car takes off in hot pursuit and catches up to the speeder in 700 meters. So the police car has traveled 700 meters by the time he catches up to the speeder, but so has the speeder, right? The speeder passes the police car, so here's one car, and here's the other. So at an instant in time, the speeder passes the police car, but the police car takes off after him and eventually catches him. So this distance is the same for both of them. It's 700 meters. The time is also going to be the same for both of them. However long that it's taken the speeder to pass the police car and travel 700 meters, that's how long it's going to take the police car to catch up. And the question wants to know, how long does it take? What is the police car's acceleration? And what is the speed of the police car? Okay, so this one actually you don't have to set the two things equal because look, you have a VAV and a delta D, you can find your delta T. So for the speeder, VAV equals delta D over delta T. So delta T is equal to delta D over VAV. So 700 meters over 30.5 repeating meters per second. Delta T equals 22.909 seconds. We're going to run, and that's repeating. So then you go over here, and now you can find A. Doing delta D is equal to VI delta T plus 1/2 A delta T squared. We're going to run out of time here, but you're going to rearrange this for A. A equals 2 delta D over T squared. So 2 times 700 divided by that 22.909 repeating seconds squared.